Welcome everyone. In this video, just take a few minutes and talk about binary patching with IDAPRO. It's a topic that comes up regularly and I actually find myself doing it quite often as well. Before we jump into the topic though, don't forget to subscribe, like, and add some comments. You have questions, suggestions, any sort of feedback, happy to help, but certainly appreciate any sort of subscribes and sharing of this content as it helps the channel grow. Okay, so for today, we're going to get into a sample program. I have the source code as well as the binary available on one of my GitHub repos called Learning Reverse Engineering. I'm going to put this file under control structures because we're going to use basically an if statement, a comparison, in order to patch the condition so that the binary always does the opposite of what it's intended to do. So you'll find simple password.c. We'll take a look at this program here in Visual Studio Code in just a minute. I also uploaded the binary. If you don't want to have to deal with compiling the program, you can find the binary in here, simple password.exe, as well as hashes if you want to verify. Okay, so what is the program? Well, as you can see, the program is quite simple. I am just doing a string comparison from the command line argument with the string CyberYeti. Yes, I am experimenting with something here, but that will be revealed hopefully later in the year. And if the argument provided matches this string, that's the important part, then we're going to print you win, otherwise you lose, or try again. Right? So here we have this if statement with this comparison, and the idea is that we want to be able to get the you win message every time we put in the wrong password. So this is just a really good example of being able to then toggle an actual nibble, half of a byte, in order to change the instructions. Okay, string compare compares the two strings. If the result is 0, that's why we're comparing to 0, then we enter this branch. Okay, so what does this program look like? Let's run simple password.exe, and I'll just give it an input of test. So that failed. I'll give it an input of the string, and you can see that we win. So what we want it to do is that anytime we put in the wrong value, that we get the other message. We change the logic by patching the program. And why we would do this is because maybe we're looking at a program, we don't want to have to, we don't actually know the password. We just patch it. I find myself doing this with malware a lot, and that maybe the malware is doing some anti-analysis checks, and I don't really want to have to deal with getting around those anti-analysis checks, so I just patch the binary to change the behavior. Okay, we'll take a look at this program in IDA. I'm already going to skip ahead here. I've adjusted the display, the default layout with IDA, and that we have this graph view with the disassembly listing on the left, and I have the hex view off to the right. And then all the other default windows I just went ahead and closed in order to save a little bit of real estate here. IDA has successfully navigated me to main. That's always one of the first things that I check. And for this video, I'm not going to spend a great deal of time analyzing the program because we can really, it's quite simple. There's not a lot of code here, and we can get right to the point where we can start our analysis. Now, sometimes you'll find that IDA doesn't always detect library functions. For example, this call to sub 404163, we know because we had the source that this is put. So I'm just going to annotate that there just to help us with our analysis a bit. We can see there's the call to string compare, and then this is where we have a classic pattern. We have a test that's testing the result of the EAX register, and then we have a conditional jump. So jump if not 0, saying jump if the 0 flag is not set. This will jump to the location, which we have our string try again. So we could use the N shortcut key and change the label here, this location. We'll just call that fail, right? That just makes it a little bit easier. Otherwise, we don't take the jump and we enter this, we don't take the jump, we enter this basic block here, or we just continue execution because we're not jumping, and that prints the you win. Okay, so what that is saying, as you saw in the original logic, we want the return value to be 0 from our call to string compare. So this is saying that if that 0 flag is not set, take the jump to the fail block, and then exit the program, otherwise enter here. You could certainly take a look at this with the decompiler that's now available. You can see that the decompiler does a very good job of recovering that code. It's essentially the same exact thing. They made the comparison a little bit different, but logically same effect, and so you could analyze that here as well. But for this purposes of this video, we'll stay here in the disassembly listing. Now, I also toggled on opcode bytes. You can get to that under Options General, number of opcode. Okay, pick a number, 7. 7 is enough because all I really want to see are what are the opcode bytes for this conditional jump. If we can change something in either the value of the test or the conditional jump, we can change the flow of the program, right? So in a situation like this, I generally just change the conditional jump. This conditional jump has the opcode 750F. The 75 is the opcode for the instruction, the jump if not 0. 0F is the displacement, the number of bytes that it's going to jump. Now, I have the hex view open so that you can see off to the right, whenever we select an instruction, you'll notice that in the hex view, it's also highlighting those corresponding bytes. And so now what we can do, if we want to patch this, we can change this conditional jump from a jump if not 0 to a jump if 0, and that will essentially invert the logic. So how do we know how to modify this? Well, if we patch the bytes, we can actually change the byte value here in the hex view and then apply that modification and then patch the actual underlying binary. So how do we know which value? Well, if you go to what I typically end up doing in a situation like this is doing a search for x86 or x64 and then the instruction that I want to research. So x86 and J and Z. And the c9x.me is a site that oftentimes comes up. What we're looking for then is the opcode 75, which is right here, 75, and then 75 and 1 byte. So jump if not 0, relative 8, relative 1 byte or 8 bits. Okay, so the opposite of that, here we have jump if 0, relative 1 byte, that would be 74. Right? So that's how we can look up and determine how we can patch that byte value back in IDA. So what that means is now that we've selected our instruction, we're synchronized here in the hex view, you can right click and edit or the shortcut key F2. And if we type in 74, see we're only actually modifying half of the byte. We're changing the 5 to a 4, that's a nibble. So we're only modifying that. Now if you do F2, that applies that modification, and you'll see that our condition here has changed, jump if 0. Now with IDA, you can't just hit debug and start running because we've only patched this in the database. So if we wanted to use this patched binary or this patched code anywhere else, what we have to do is we have to go to Edit, Patch Program, and Apply Patches to Input File. Right? Now if we debug or now if we want to use this modified binary in other tools, such as a standalone debugger or some other RE tool, now that modification will take place. Otherwise, right now, all we've done is we've patched the IDA database. Right? Even I won't do that yet. Even if we hit and try to do debugger, so we try to debug, you'll see that not only do you get the typical warning about debugging, be careful, but then you're also going to get this message about the database has been patched, but not the underlying file. So there may be some inconsistencies. Right? I don't want to debug those, so we'll go ahead and we'll stop that session. Okay, so now if we go to Edit, Patch Program, Apply Patches to Input File, basically you can just select the defaults. So Start EA, End EA, that's just essentially the range that we are modifying, which in this case will be the entirety of our file. I do encourage you to check Create Backup. Anytime that I am modifying a binary file, I want to make sure that I have either the original, I create a backup of the original, or I simply have access to the original, maybe not in the analysis VM or something. But that way, if something goes wrong, the modification doesn't work quite as you anticipate or expect, you can recover a little bit more quickly. Click OK, and now you have that patched file. So I'm going to close IDA. I'm not going to save this database. And then reopen IDA with that patched binary. And the reason I did that is so that we know then that we're not looking at any modified database. IDA analyzed that binary anew, and there is the opposite condition. Now, of course, maybe a more complete test or just another part of just testing that we patched that correctly would be to run the binary. And you can see now that we're executing it with the wrong input, and we're getting the uwin message. So we know now that we have in fact converted or inverted that logic, so that we've changed the structure of that if statement, and now it's doing the opposite of what it intended. So It's not always going to be that simple and straightforward, but oftentimes when you need to patch a binary, this is a quick and easy way to do it. Using IDA to not only patch the bytes that you're interested in changing, but then also applying those patches to the underlying file and now being able to further analyze that modified binary. So just hoping to help build on your understanding and usage of tools like IDA Pro. Hope you enjoyed, and I'll talk to you all in a future video.